Hello and welcome back to the BIN2BEAN Training Series on awareness raising and community engagement. In this module, we'll learn about the properties of compost and why understanding them also means understanding soil itself. Soil is not just a mixture of minerals such as clay and sand, or stones covered by a dark surface. The top layer of soil also contains humus, the result of the biochemical decomposition of plant residues by millions of organisms, of which less than 10% are well known to science. Soil scientists define humus as the totality of organic substances in soil, remains of plants, animals, fungi, and bacteria that are broken down into molecular and mineral components by microorganisms in the upper soil layer. The humus content of soil is best described by its organic carbon content, SOC, since analyzing single components would not be meaningful. Harvesting always removes carbon and nutrients, which is why fields often show a low SOC content. By contrast, grassland has around 10% SOC, and swamps or marshes show the highest concentrations of organic matter. To maintain soil fertility, it is therefore necessary to add materials that compensate for these losses. Besides ploughing in plant residues, more material is needed that can be broken down into humus. Compost made from waste biomass is well suited because it contains a high proportion of organic carbon together with nutrients such as nitrogen and phosphorus. For this reason, compost from organic waste is considered a soil improver, as we already saw in the legal background in Module 2. Humus can be characterized by how accessible it is to organisms and plants. Some humic substances are easily available, and microorganisms use them as nourishment. These disappear quickly. Others, known as refractory humus, remain in soil for years. The second fraction is responsible for many important soil properties. It increases water-holding capacity, stores nutrients, and immobilizes heavy metals or other soluble compounds that could harm plants. Compost contains humic substances and therefore acts as a true soil improver. A striking example can be seen in the comparison of two neighboring fields after heavy rainfall. One field, managed conventionally without compost for several years, became almost flooded. The other, managed ecologically and enriched with compost, absorbed the water thanks to its higher humus content. This shows how a high SOC level increases the resilience of soils, protecting them from erosion and from drought. Let's continue with the role of compost in climate protection. If organic waste is landfilled, it decomposes into methane and other gases over time. Methane is a very potent greenhouse gas, with a global warming potential around 25 times that of carbon dioxide. This is why the landfilling of biodegradable waste is to be completely prohibited in Europe. Incineration of residual waste also produces carbon dioxide. In contrast, recovering organic matter through composting decreases greenhouse gas emissions. The refractory part of humus even stores carbon in soil, helping to mitigate climate change by slowing down emissions. This process of carbon sequestration is already recognized in European climate protection policy as one way of compensating for unavoidable emissions. Maps from the European Soil Observatory highlight large areas of Europe suffering from a lack of organic carbon. For 6% of all soils, the loss of organic carbon is already considered critical. To prevent further losses, it is important to apply compost and other soil improvers. According to the European Environment Agency, repeated application of good quality compost can improve the soil's ability to retain water and nutrients, to store carbon, and to increase fertility. Findings from the Life Soil Comp project confirm these benefits. The project showed that applying 20% more compost reduced the use of water, pesticides, and mineral fertilizers by 7% per farm, while increasing productivity by 10%. Despite the high demand for soil improvers across Europe, there is a shortage of good quality compost. Increasing the collection and processing of bio-waste is therefore a major opportunity to improve soil resilience. Mixed waste can also be treated biologically, as in MBT facilities, but the result is compost that is contaminated and unusable on soils. It usually ends up in landfills or in quarries. For this reason, it is essential to separate biowaste at source. Kitchen and green waste must be collected separately, and the input quality must be high. Separately collected biowaste should not contain more than 3% impurities, such as plastics, glass, or dust. In summary, compost made from biowaste is essential to maintain the fertility of European soils. It improves the soil's capacity to store and filter water, reduces the mobility of harmful substances, and contributes to climate protection through carbon sequestration. But this is only possible if households, restaurants, hotels, markets, and the food industry carefully separate biowaste at source so that it can be processed into safe and effective soil improvers. In the next video, we will learn about how to motivate to separate and recycle biowaste. See you in the next module.